Alright, in this video I'm going to do page 7 of note 2 from Calc C, which is just a lot of work, so I'm really just working through examples. If you already know what you're doing, you might not need to watch this. If you just want to see the practice, go for it. Otherwise, you could scroll through and just see the answers that I get and compare. So the first question is I want to write the third degree Taylor polynomial for a function. So here's a function. F of x is 1 over 1 plus x, and that's at x equals 0. So previous to this, I've been given a table of values, and I just plugged right in. I was given a way of determining the value of the nth derivative at a point, and then I created the table, and then I plugged in. Here I'm going to have to actually find the derivatives and the values. So it's a little more work, but I tend to think of this as kind of a standard problem. And this one, it turns out, is actually famous, so if you've looked ahead, you might already know the answer to this problem. So I set up my table with n, the nth derivative, and then the nth derivative at 0, and now I need to find those. So what I'm going to do is I'm going to rewrite the function using a negative exponent because it makes it a little easier to find all the derivatives in this case. So I'm going to make it 1 plus x to the negative first, and then I'm going to power rule, chain rule my way through these derivatives. So keep bringing down, subtracting 1, bring down, subtract 1. You might notice that those coefficients are factorials, but you might not notice that, and that's fine too, because we don't really need to know that because we're not generalizing at this point. So now I need to plug in 0. So I get those values, and now I'm just going to go ahead and use the formula. So f of x is approximately, so I'm just plugging straight into the formula. And I get that. And remember, I'm writing, in my mind, I'm writing x minus 0 to the n, but no one really writes that. So I'm going to simplify this because it gets a lot cleaner. Because 2 factorial is 2 and 3 factorial is 6. This actually just cleans way up into 1 minus x plus x squared minus x cubed. And that's the third degree Taylor polynomial at 0. Another name for that is the Maclaurin polynomial. Anything centered at 0, you could call it Maclaurin polynomial. I'm not very good at spelling Maclaurin, by the way, so if you look through my notes, you might find some mistakes. All right, let's do another one. So now we want to do this same process, so third degree again, for arctan, or tan inverse, at x equals 0. So let's create our table. And this is only slightly worse. It doesn't really get bad until we try to find the third derivative. So the original function is the 0th derivative. First derivative is 1 over 1 plus x squared, which I'm going to write with a negative exponent. There's actually no advantage to doing that here. Now I'm going to take the derivative, which involves quite a bit of the chain rule. So I get negative 2x over 1 plus x squared squared. And now I need to, I'm never going to fit this in that spot, so I'm going to put this down here. I'm going to use the quotient rule. So bottom, derivative of the top, minus top, derivative of the bottom, which is like a chain rule type thing, all over the bottom squared. Okay, so it's pretty ambitious. I was never going to get that in there. Now I need to plug 0 into all of these. So you get that's kind of nice, actually. If you get zeros when you plug in, it's kind of an ideal scenario. All right, let's just plug into our formula that we now have memorized, which is nth derivative at a x minus a to the n all over n factorial, and then you just keep going. So to start it off, approximately. So I tend to write things even if they cancel out. I just find it helpful to maintain the pattern that way. So I get that, and I'm going to simplify again because it does. Kind of use your discretion as to when to simplify. And there you go. That's the third degree Taylor polynomial, which is it's surprisingly simple, right? I mean, you would think with arctan, well, arctan's a simple curve, but there we go. So let's take a look at the next one. So f of x is 1 over 1 plus x. This time we're going to center it at 1. So it's essentially the problem that we did in A, except now it's centered at 1. So we make our table. So we're going to have to find the derivatives. It's convenient, again, to use negative exponents. Basically, if you don't have to use the chain rule a lot, using negative exponents is the way to go. Also, you do this particular problem over and over again, so eventually you just kind of like have a sense of what to do. Alright, so there are 3 derivatives, and now we have to plug in 1, so we're not plugging in 0 this time. It's actually maybe the hardest thing to remember, is when you're plugging in, not even the centering, because like I harp on and on about that, and then eventually people just forget what to plug into the derivatives. So let's use our formula. So approximately. So again, I'm doing the thing where I could write 1 over 2 factorial over 1 factorial, but I'm just dropping things into the denominator as soon as possible. If you got to this point in calculus, hopefully you kind of remember that. Why did I write to the 4th there? That should be to the 3rd. My bad. Not gonna fix that though, because it's pain the. Well, I guess I can try. Here we go. I'm gonna try to fix this. Fix it on the fly. So you are not to the 4th. You are to the 3rd. Okay. So I guess that's fixed. But I'm guessing that I made the same mistake when I cleaned it up. So let's see. And yes, I did. Nice work, me. Okay, so let me fix that one too. How big this eraser is. So that should actually be to the 3rd because we're writing a 3rd degree polynomial. So my mistake. Alright, and we have one more problem to go. And I'll be honest with you, I kind of cheated on this one because the derivatives get out of hand pretty fast. So what I did, instead of doing this by hand, is I broke out my Inspire and I used it to create the table. So here is a picture of that. So in the first column I have the nth derivative, so 0, 1, 2, 3. Then what I did was I had the calculator in a spreadsheet just find the first, second, and third derivatives, and then in the next column I had it evaluate those derivatives at 1. So I just kind of used technology appropriately. Look at that third derivative, or third derivative. You don't want to find that. And then you plug in 1 and you get 0 anyway, so you did all that work for kind of nothing. But let's finish this problem. So let's see if I messed up the exponents again. Sometimes I get stuck in a pattern. I did not. Okay, so I didn't actually write the third one where I would have had a chance to screw up the exponents because the coefficient is 0 anyway, so it just drops out. But so that's page 7. That's 4 different examples. They're sort of labor intensive, but they're worth it because they help kind of hammer that formula into your brain. Hope you found this helpful, and I'll see you in the next video. Good luck.